Hello and welcome to another wonderful adventure. Mr. Wernau does your homework. All right, we're going to take a look at a few examples from your homework for tonight. And if you just watch this video for the fun of it, we're just going to take a look at a bunch of integrals here using some of our special tricks. So the first one we have is we want the integral of x cubed times natural log of x. This is our integration by parts. Here we have an algebraic function, and over here we have our transcendental function. So typically we would let the algebraic function be u, and we would let the transcendental be dv. But the problem is, if I try to use natural log as my dv, if I try to integrate it, we run into a big problem. We don't know the antiderivative of natural log. Hint, it is not 1 over x, that's the derivative, be careful. So this is a very rare case that we're going to let our transcendental function be the natural log of x, and we're going to let our dv here be the x cubed dx. Don't forget, integration by parts works like this. The antiderivative of u, dv, becomes u times v minus the antiderivative of v du. So since we have u, we have to find du, so we're going to look at the derivative. That we do know, 1 over x dx. V, if we're given dv, we have to find v, so we have to integrate here, and that is, let's see here, that becomes, whoops, our rule says we are going to add 1, so we get x to the 4th over 4. I don't know, my thing is going crazy today. So now when I rewrite my integral using my rule, u times v, we would get x to the 4th over 4 natural log of x minus the antiderivative of v du. Now I can factor out the 1/4 here, and that's going to give me x cubed dx. Now this, I know how to integrate. It is just my basic power rule. So we're going to get x to the 4th over 4 natural log of x minus 1/4 times, and of course this becomes x to the 4th over 4 plus c1. Some teachers want you to simplify that, so we might go ahead and do that. We get minus 1/16 x to the 4th plus your constant of integration. And there's your antiderivative. Alright, the next one's a little bit tougher. This is going to be it's a little bit tougher right here. Now, there's probably a few ways I can do this one. I could probably use my arc trigs by splitting the fraction, because if I take the derivative of the bottom here, we would get 2x minus 5. I could minus 4 and add 4 here. But remember, here I can factor the bottom, and the rule is if I can factor the bottom, we are going to use our partial fractions. If I did it the other way, most likely I'll wind up with a case that does not fit either my arc sine or my arc tangent. In this case, it would be my arc sine rule. So partial fraction is the best way to go here because I can factor the bottom. And that's going to give me x minus 2, x minus 3 right there. So if I do my partial fraction over x minus 2, x minus 3, that's going to become a over x minus 2 plus b over x minus 3. If you forgot how to do these, take a look at one of my other videos. They're amazing, I must say so myself. Alright, so I'm going to multiply by my LCD, which is the x minus 2, x minus 3, and that's going to give me 2x minus 1 equals a times x minus 3 plus b times x minus 2. And now we're going to apply that Oliver Heaviside method, which means we're going to look for those zeros here, right? We're going to find two x values to make a system. And Heaviside said, hey, just use the zeros, it's a lot easier. Plugging in 3 here, that becomes 6 minus 1, or 5, equals, that's 0a, plus 3, plus, that's terrible. Let me see, 3 minus 1 is just 1b. What? Algebra's wrong. So b is 5 there, not minus 5. My other 0 would be 2. Plugging this in, we would get 4 minus 1, which is 3, equals, let's plug in the 2 here, we get negative 1a plus 0b, and we get a is negative 3. And there's not what we want, because now what we can do is rewrite our integral. So my new integral is going to be from 4 to 5. Plug this in. Remember, this becomes a over x minus 2, so negative 3 over x minus 2, plus b, which is we said is 5 over x minus 3. Whoops, oh no, I forgot my differential. Don't forget the dx. Okay, don't want you to get all this work correct and then forget your differential here. Alright, so I'm going to use u substitution. X is u minus 2, du is dx. Remember, I'm just really checking to see if I'm dividing by anything, and I'm not. And this becomes negative 3 natural log x minus 2. Do my u substitution here. My du is just dx, and that's going to give me plus 5 natural log x minus 3, and we evaluate that from 4 to 5. It's going to look ugly, but you know what though? If it starts to look nice, that's when you're probably doing it wrong right now. Alright, so let's see here. Let's plug in our f of 5 minus f of 4. Big parentheses, big hug, so it looks, so we can get our answer here. Plug in the 5, we get negative 3 natural log 5 minus 2, which is just 3, plus 5 natural log 5 minus 3, which is 2. So we get natural log of 2. Minus, plug in the 4, negative 3 natural log of 2. I probably should use my, I guess going to have using my absolute values, even though I don't need them here. And that becomes plus 5 natural log of 1. That's easy. That's a 0 right there. So here's our answer. Know what you're thinking, Mr. Wernau, can we simplify this? Absolutely you can. Ready? So we would get, if we were to simplify it, negative 3 natural log of 3 plus 5 natural log of 2 plus 3, so plus 8 natural log of 2. And you can leave it like that if you like. Alright, so there's the first two examples right there. So let's see. Let's take a look at another little bit of goodies. This is number 3 from your homework. I know it seems like I'm going in order here, right? So, but I want to take a look at number 3 because this is one that a lot of students tend to miss on quizzes and tests, this type of question right here. So for number 3, we want to integrate from negative 1 to root 2 dx over, and this becomes the square root of 4 minus 25x squared. Now, obviously, this is definitely going to be our arc sine. And arc sine, my rule says arc sine of u over a. So when we simplify this one, well, my a is going to be 2. But this is where people mess up. My u is 5x. So my du is going to be 5 dx. I have to divide. Okay, don't forget, this is the most important step. We need to make sure what we are doing here, in this case, we're going to divide everything by 5. So when I write out my answer, we are going to get the arc sine of 5x over 2. But remember, we have to divide my answer by 5. And that's what a lot of people tend to forget. There's that constant. It's from my u substitution. And this is going to be evaluated from negative 1 to 2, root 2. And the answer is not pretty. I'm factoring up to 1/5. This becomes the arc sine of 5 root 2 over 2 minus the arc sine, if I plug in the negative 1, negative 5 over 2. And these are not known. Those are not one of your known trig values, so you're not expected to be able to simplify something like that. You would just leave it alone, and that would be your answer right there. All right, if you go to video number 2, we'll take a look at a couple more examples. I'll see you then.